Hello students, this is Professor Smolny again. I'm talking about Chapter 4, entitled Customizing AI Systems, Allowing Others to Modify and Implement the AI. So, following from Chapter 3, Chapter 4 has to deal with how exactly we as programmers go about implementing our AI systems so that they are more accessible to other departments within, a supposed game company or a game project. And basically weighing the benefits and negatives of any one particular system that we might implement. The key chapter questions for this chapter are: early video games were written in programming languages, often assembly language and C. What changes have taken place to make scripting languages useful tools in video games? What is an example of a game system that requires minimal setup by a game designer, and when is the kind of system useful? What is an example of a game system that requires that substantial information be supplied by a game designer, and what are its advantages? Building a custom script system is time-consuming. What are two ways to make game scripting available more quickly? What are the advantages and drawbacks of text-based scripting? Given unlimited resources, what are some ways to address the drawbacks? So, at the very beginning of this chapter, the author goes into explain two different types of systems, and this is a common philosophy throughout programming and even product design. The idea of a black box versus a white box system. Black box systems are very easy to use. As you can see from this picture, it's basically you just trigger it whenever you're ready to use it, and out comes the output. It should be a very simple system, very easy to understand. Whereas a white box, in addition to having some sort of interface, has the ability for someone to basically define more clearly what the input is. So you have more than just one sort of input. I mean, in this case, it's got a bunch of switches and toggles and I guess knobs that one could turn. So black box is simple, white box is more complex, but allows for more complex input. And so, following up on another example of a black box versus a white box situation. In a black box, you have well-defined problems, and it's a very repetitive behavior. And the author goes on to talk about, an automatic transition versus a manual transition. An automatic transition, you have a very high-level problem. I need to go forward, I need to go in reverse, and I need to go in park. Versus a white box in which the user would actually have more control over which gear they're in. In the black box, it's not important to the end user what's going on underneath. They just need to know, I need to go forward, I'm going to go forward. Whereas in the white box, you have the user actually deciding, okay, I'm going forward, but am I in first gear, am I in second gear, do I want to downshift now or upshift? The control is left in their hands. It's more complex, for the end user to actually, figure out how to use the system, but it gives them more control at the same time. And so in game development, black boxes are very useful when it's basically you want a quick solution. You don't need anybody to basically define any parameters. I need the guy to move. It's a very simple operation. He's just going to go ahead and move. I don't need to think about it. White boxes allow for much more collaborative projects because rather than relying entirely on a programmer to figure out what the equation is behind it, the programmer can just basically create equations that are filled in with parameters that a designer decides to the end values for. So, suppose you had different enemies in the game. The designer could go and tweak the different speeds at which they're able to fire, when they're able to walk, how far they could see, and it allows for a much wider range of possibilities. It's also a lot easier to actually do the white box from the programming standpoint because you're actually outsourcing or offsourcing the work to the designer, saying, okay, here are the tools, you go create it. I'm not going to bother. So depending on the dynamic of your team, a white box may be a better solution. You only have one programmer and he can't devote all his time to figuring out balance in the game. You can let the designer do that. And also this allows for more iterative development in that rather than it being hard-coded in, it can be changed fairly dynamically in a white box. So if at one point the designer says, you know what, this monster, he moves too fast, it's too hard for the player, it's a really quick change versus having to go ask the programmer, hey, can you make this change, and then waiting to get it back. Oh, it's still too high. There's more back and forth there. Whereas in the white box, the programmer can just go ahead and do what he needs to do. And along that point is the idea of a data-driven system. So to enable the designer to basically be able to quickly set these parameters, there might be a file that basically has them all written out. And rather than bugging the programmer to change the code where these same values could be entered there, they can just go ahead, change a text file, change an XML file, and quickly see how different changing different numbers would actually affect the balance of the game. Also, by using a data-driven system, we can also determine if we want certain units to have certain behaviors. The example the book gives is Halo 2. There are the smaller units, I think they're called grunts. At a certain point, if they're startled, they'll just run away because they're small and weak and they don't want to get killed, versus the the elites, who are basically the battle-tested heroes who won't flinch when they're tested. They will never flee. So you can have the ability to control which units have which behaviors, also by a data file. This allows much more tweaking on the side of the designer, offshores it all off the developer's plate, allows them to work on other more complex problems, like frame rate and performance. As an alternative to the data-driven system, we can also have a rule-based system in which the designer would be able to actually just determine when events would trigger based on what's going on. This isn't something we're really covering in Chapter 4 and will be left for a later chapter. So scripting systems. So building off this idea that AI is not strictly inherent to programmers. I mean, it exists well beyond the scope of just programming the game. Designers are responsible for using these systems to basically make the game enjoyable and fun. And the next couple of slides are going to focus on ideas of using a less restrictive or less complex language to actually enable the designers to accomplish that goal. They are not programmers. They cannot be expected to understand programming concepts, and you would not even want them touching the code because that is not their focus. Their focus is on using the different rules and using the different systems to basically build a complex but enjoyable experience. Skip ahead past this slide. Oh, so I guess these last two slides are just kind of referencing different scripting languages. There's a lot of them out there. Lua is one that gets a lot of attention. There are several others. They will go into the differences between them. Unreal Tournament also has Unreal Script. Also has some benefits and drawbacks over others. And so the book goes over exactly what these advantages are. Lua is one that gets used a lot in that it's object-oriented, so it allows designers and programmers to reuse features and use the concepts that are familiar to object-oriented, inheritance functions, so that to